Okay, hi. So today's problem is sliding window maximum. I already solved it like day ago, but actually I didn't like the solution much, and I saw another one. So let me program first the one that I didn't like, and then I'll try to dive into the one that's better, but still we'll see if I will manage to understand it. So based on this problem, we have a sequence of numbers, and we have a sliding width of k, and on every sequence or subsequence of length k, like the window of numbers of length k, we should find the maximum and return all these maximums as we slide the window. Like first window gonna be here, second gonna be here. So the maximum for the first was 3, the maximum for the second was is 3 again. The maximum for the third is 5. The maximum for the fourth is 5. The maximum for the fifth is 6, and the maximum for the seventh is 7. So 3, 3, 5, 5, 6, 7. So I have an idea to do this with priority queue. So initially I'll add all the elements of all k initial elements to the priority queue, and I'll add them like value and the index of that value, and then I'll try to get the value of the priority queue. So it's going to be mean he we need to find max, so it's going to be max heap, and I'll gonna first every time the window moves, I'll offer a new element to the priority queue, and then I'll try to get the maximum out of the priority queue. But the problem is that um, there might be indexes that's already out of the window indexes range. So I need, when I'm gonna get the maximum, I need to check if that maximum is within the window. If yes, I'll just add it to the output. If no, I'll continue polling the elements, removing elements from the, and if the I'll continue picking the element, and if the element is out of the window bounds, I'll evict this element, like call poll, and then I'll try to do the next, the I'll try to do the again check the maximum element, pick it, then you check its bounds. If it's within the window, yes, okay, save it into the output. If no, just continue again and evict that element before the continuing. So I'm gonna have priority queue with integers. I can even go with just indices. Yeah, I can easily go with indices, integer. So I have priority queue equals new priority queue. Then gonna be index 1, index 2, and then I'm gonna just compare integer, compare nums index 1 and then index 2. And because I wanna have mean max heap, I wanna do it the reverse order. and then I'll do the for int I equals 0, I less than k, I plus plus, and then I'll just pq over I, and then I'll have the output array equals new int, and the output array gonna be, let's say we have the nums length 5. Oh, like here, nums is length num is length of length 8. So we do the following: 8 and k equals 3, and we have 1, 2, 3, 4, 5, 6, 6 windows. So we need to basically subtract, let's say we have int n equals nums length, so we do n minus k plus 1. It's gonna be the size of the length of our number of windows we're gonna have plugin windows in the sequence of length n, and the output 1 or 0 gonna be pq peak, and then nums of this pq peak, and then while I equals 1, I less than n, I plus plus. So on every move I'm gonna add the element to the priority queue, pq offer, and then I, and then I need to do this while pq peak. So while the index is so the bounds of the window for the window, the left bound for the window, so we're gonna have like on the index, okay, so index k, bounds for the window are gonna be, let's say here you have 4. If we're gonna pick 4, then I minus k, yeah. If it's less than I minus k, I'm gonna have pq poll, and then I'm gonna save the output 1 plus output I minus k plus 1, gonna be pq peak, and then nums, and then I'm gonna return the output. So as I said initially, I have a priority queue based on the order is based on the values in the nums array, and in priority queue I store the indexes of those values, and the ordering is based on the like reverse like a reverse increasing order, so like decreasing order. So at the head, or like at the root of the heap, I'm gonna have the maximum element. Initially I'm gonna go through the or initial window of length k, and offer all the indexes to the PQ, and then initially I save the initial value of the result equals PQ peak, get the index of the maximum value in the current set of get the index that has the maximum value in nums, and it should be of length k. The window should be of length k. In this case, it's satisfies the requirement, and then I'll move the window. So I'll add an additional element, and then I check what the maximum index value index of the maximum value in our heap, and if the index is out of the bounds of the window, then I'm gonna just exclude the element from the heap. Otherwise, I found a maximum that's within the bounds, and I'll just save the output into the output array. So k, there might be edge case when k is greater than n. Can it be? No, it cannot be based on this. So let me try to run it. Mm. So when I is equal k, in this case, I is equal 1, we have PQ over I. Let's say we got the PQ peak. Here less of equal. Mm-hmm. Mm. Here nums. Yeah, so that's it. Few typos, but yeah, let me check what we have here. So they have DAC. So it sounds like this one is very similar to monotonic stack. So the deck is basically monotonic stack. So they add the first. I wonder why this check is needed. So seems like this is monotonic stack. They always keep like so we have, let's say, if it is lower value, we add it to the monotonic stack. If we see the higher values at the top of the stack, we're gonna remove all elements until we see the higher values at the current one, and then push it to the head. And then yeah, but how we gonna remove all the, let's say we have decreasing sequence, and how they gonna remove the tail always? Okay, so before that, I remember I solved the problem um, with a slightly different technique, where I was having that left and right array, and what I did, I what concerns me is this divide model divide. So it seems like you have a maximum like in a discrete intervals and non-overlapping windows. Okay, I'm probably gonna wrap up. Mhm. So I remember there were two errors. I probably solved it within like reasonable timing, but there were two errors. I didn't do the paper tracing, so I guess it's fail. Okay, thanks.